Okay, let's get right into it. We're talking about AI that can learn, that can adapt, and yeah, that can literally upgrade itself. This is all thanks to a new protocol called autogenesis, and it might just be the next huge leap in artificial intelligence. You know, for all the amazing things today's powerful AI agents can do, they have a secret flaw. It's this hidden weakness, a really fundamental problem that's holding them back from what they could truly become. So here's the issue. They're surprisingly brittle, you know? When a cutting-edge AI runs into a new challenge, or even just a simple error it hasn't seen before, it often just breaks. It just stops. It can't adapt on the fly, and it definitely can't fix its own mistakes. It's basically stuck with the programming it was born with. But what if they could? I mean, really think about it. What if an AI could learn from its failures, rewrite its own code, and actually evolve? What if it could not only spot its own bugs, but squash them, all by itself? Well, that's exactly the idea we're going to unpack today. All right, let's really dig into what the researchers are calling the brittle AI problem. Because once you get this, you'll see exactly why a self-evolving AI is such an absolute game changer. So this really frames the whole shift we're talking about perfectly. On the left, you've got today's AI. It's hard-coded, it's static. Everything from its logic to its tools is basically locked in place. But on the right, that's the autogenesis vision, an AI that's built from the ground up to be dynamic and to constantly evolve on its own. Okay, so before a system like this could even exist, the researchers had to solve three huge problems. First up, decoupling. Think of it like this. The agent's brain was all tangled up with its tools, a real mess. You couldn't upgrade one part without breaking something else. Second was safety and auditability. There was no version control, no undo button. If an AI tried to change itself and messed up, well, that mistake could be permanent. And third, formalism. There just wasn't a standard repeatable process for an AI to actually make smart improvements. It was all a bit chaotic. And this is where we get to the solution. Autogenesis isn't just another shiny new AI model. It's a protocol, a set of rules, a standardized framework designed specifically to let AI evolve safely and in a controlled way. Now, the real genius here is how it separates the what from the how. Imagine a factory that upgrades itself. You've got all the parts on the assembly line. That's the what that evolves. And then you have the automated R&D department that's constantly improving the whole process. That's the how it evolves. Autogenesis basically created a rulebook for both layers. Okay, let's break down that first layer. This is all about creating a library of parts. It's officially called the resource protocol layer, but honestly, just think of it as the factory's massive library of standardized, interchangeable components. And at the very heart of this layer is this idea of a resource. So in the world of autogenesis, a resource is any part of the agent, a prompt, a specific tool, even its memory. Each one is treated as a separate, standardized part. It makes everything modular, basically like a giant set of high-tech Lego bricks. So here they are, the 5 core building blocks that the protocol lays out. You've got prompts, the agents themselves, their tools, the environments they work in, and, of course, their memory. By making each of these a standard resource, the system can easily swap them, upgrade them, and keep track of every single version on its own. Right, so if layer 1 is the library of parts, then layer 2 is the engine that actually drives all the improvement. This is what's called the self-evolution protocol. This is basically that automated R&D department we talked about, and it runs on this constant, super rigorous 5-step loop. First, it reflects on how it did. Then, it selects one specific part to make better. It comes up with a way to improve it, then it has to evaluate whether that change actually made things better. And only if it did does it commit the new and improved version to the system. It's basically the scientific method, but for an AI to improve itself, baked right in. And this right here is so important. The researchers put it perfectly. Evolution is not a random walk, but a directed trajectory, traceable and reversible. What that really means is that every single change is intentional, it's documented, it's tested, and, crucially, it can be rolled back if it doesn't work out. It's basically evolution with a built-in safety net. So the theory sounds great, right? It's really elegant. But the big question is, does it actually work in the real world? Well, let's take a look at the data from some seriously tough benchmarks. Check this out. On the Gaia benchmark, which is designed to test agents on these really complex multi-step tasks, the results are, well, they're striking. On the absolutely hardest problems, the regular baseline agent got it right about 61% of the time. But the autogenesis agent, the one that could evolve itself, it shot up to over 81%. That's a massive 33% jump on the problems where it counts the most. And it's not just about making the best models better. Autogenesis actually helps weaker models punch way above their weight class. On a really tough math benchmark, a less capable model saw its accuracy improve by more than 71%. The protocol basically gave it the ability to find and fix its own mistakes in reasoning, one step at a time. And the gains aren't just in math either. Take coding. On these complex leet code challenges, the agent's pass rate shot up by almost 27%. You gotta let that sink in. It is literally teaching itself how to write better code. And get this, it's not just about getting the right answer. The evolved solutions are also way more efficient. The AI doesn't just learn to be more correct, it learns to be faster. For example, in C++ coding tasks, its solutions became over 46% faster on average. That's a huge deal. So, when you put all this together, what does it actually mean for the future of how we build AI? Well, it points to a really fundamental shift. We're moving away from a world of manual prompt engineering, where humans are constantly babysitting and tweaking AI systems, and we're moving toward a future of automated protocol engineering, where the systems themselves can start to maintain and improve themselves. And that leaves us with a pretty fascinating and honestly a pretty powerful question to think about. For decades, we've been building tools to help us think and create. But what happens when those tools start improving themselves, maybe at a scale and speed that we can't even keep up with? That's not science fiction anymore. It's the future we are stepping into right now.